All right, folks. Then welcome to the session of trying to demystify how join happens on a relational database. So let's again break down the problem statement of what we mean by this. So join is like you have two tables. One table has country capital as the information, and then another table has user comma country as the input data set. And imagine both of them are in JSON format. JSON simply means that key value pairs inside the curly braces. Yeah. And what you have to do is you have to somehow join these two files or these two tables. And at the end of the day, you have to provide an output saying that user country capital. I'll repeat the data part once again. There are two data files. One is having country capital, the other one is having user comma country. Finally, you have to print user comma country comma capital as my output. So if I give you this problem statement, most probably all the folks who are using databases, you will create two tables. You will upload your data into the database and you will run a SQL join asking for an inner join among both of them. And then you will get the output. But the question is, if you just look deeply into a database, how does it do this work? The reason being, a database itself or the database program, the server program of the database is written in C++. Let's say if it's even written in Python. Python, C++, Java doesn't understand SQL because if you learn Python, what will you learn? You will learn the data types, you will learn the for loop, while loop, you will learn about the file handling, open, close, you will learn about the relational operator. But there is no entity like SQL in Python. Same goes with Java, same goes with C. So it means that none of these programming languages in which the database server is written, it understands SQL. So how is it possible that you type in something in SQL? The SQL statement goes to a database process. The database process somehow is able to do the join. It means that we have to go a level deep into it just to understand the database server is nothing but a client server program to interact with to begin with. And then it is also doing file handling because end of the day, your data in a file in your database is getting stored on a hard disk. And what is the data driven reasoning for that? If you shut down your database, you close your laptop, you take out the power, you resync the power cable in your laptop, and then you restart it again, you will see that your data has not been lost. If your data was persisted in RAM, the data would have been lost. Because it's persisted on the hard disk, it's not lost. So it simply means that your database is also using your hard disk or your file system to store your data. Just for the interaction, it is using the RAM. So it's also caching the part of your metadata. Example, create table schema in RAM. But just keep in mind, it's caching. It's also storing even the schema in your file, in your data. So at a broad level, at a very broad level, what you can think of is your database is a client server program. It has the capability to cache some data in memory. It has a capability to store the same data on hard disk also. It supports two kind of information. One is the metadata. Example, the table information. Example, hey, this is my table name. These are my column names, blah, blah, blah. Then it has the actual data. Based on adhering to the schema, whatever actual data you insert, that gets saved in the data part of it. And that's why this notion of DML and DDL, data manipulation language and data definition language. Data definition language pertains to the meta information, and data manipulation language pertains to when you access the actual data to do some kind of joins and group by. Also keep in mind something very interesting that this client server program doesn't understand SQL. It means that whenever the SQL code is coming or whatever SQL statement is coming as a string, there is somebody who is parsing it, creating a logic out of that, and then you are able to do the join. So there is a parsing happening of the SQL statements as well. All right. So again, you tie it back, you will realize that your meta information of your database is nothing but that's the way how you will serialize and deserialize the data. So you have a schema information. You say that insert into table blah blah blah. It goes to the database. Database first of all verifies, hey, is it adhering to the schema? If yes, how do I store it? The first one, if you say example username as string. Oh, I have to store the first as a string. String means what? Every character is stored as 1 byte onto the file system. So this is the serialization part of it. You get some data, it creates an object in memory, and the object has to be flushed onto or appended onto the disk on your hard disk. When you say select star from table, what it is doing? It is getting the byte array from your file onto the RAM. Then it is taking the schema, mapping it back into an object. That object is serialized. Deserialized first of all. The object is created. It is serialized again, sent to the client, and then the client again deserializes back and shows that on your screen. So again, the same idea, there is no difference. So what I am trying to correlate here is, if you understand the nitty-gritties of a database, that forms the basis of your distributed system. Because as I mentioned, even in distributed system, it's all about, if you look at a single node, right? It's about a couple of things: consensus building, client server program, file handling, last but not the least, serialization and deserialization. So with this, let's start our session of how to join two dataset, or let's say if you wanted to do it through a raw program, how would you have achieved it? My name is Kunal Gautam. I work as a principal architect for one of the bank companies. Have in total 60 plus years of experience, worked with 50 plus customers across 20 plus countries at the moment, have been a speaker at multiple conferences around the globe. The most important being the Budapest, LinuxCon, Korea, uh, Germany, India. All right. So let's go ahead and go for a deep dive into the join. So we'll start with two data set, as I mentioned: country, capital, user, country, both in the JSON format. So, and what is the expected output? The expected output is user, country, capital. Just take a pause and think about which data set will be small in size and which data set will be bigger in size. And the answer would be the country, comma capital would be very small, given that, if I'm not wrong, it's like 190, 196 countries are there. So pretty much this data set will be a very small number. On the other hand, user country, this can be a very big file. Why? There are 7 billion people on the planet. If I take all 7 billion people and map it to the country and I ask for the capital, this data size, this data set can go into like multi-gigabyte file. This data set would be not even like 10 MB, 1 MB rather, right? Just think about it, because you will have the name and the country, and that has to be repeated by 1.7 billion. Even if one is like a half a kilobyte, or for simplicity, let's make it 1 kilobyte. Yeah. So 1 kilobyte into 1 billion, that's already like megabyte, gigabyte, right? So 1000 GB, billion is 1 gig, mega is megabyte, billion is 1 gig, and then you have thousand into, you do into 1,000 of that, and that's how you get such a big number. All right. So what are the three options that we have? So the first option is you read both the files into memory. So what you're doing is you are reading both the files and you're creating a hash map, or let's say it's a hash map in Java or dictionary in Python. And what you're doing is, in the first dictionary, you are storing user, comma, country. In the second dictionary, what you're storing, country, comma, capital. Now you loop through the first dictionary, you get the first row, and then you do a cherry picking, or let's say you do a lookup in the second dictionary, and that's how you're able to enrich the data. I'll read it once again. So first hash map has user, country, second hash map has country, capital. All you should be doing is, you can just do iterate through the first one, user, country, you do a lookup in the second dictionary, and then you are able to produce the result. What are the pros of it? First of all, it's super fast because it's pulling all the data in memory, and you can get the work done like super easily. The challenge with this is, if my RAM is 10 gigs and if my user, comma, country is like a 100 gig file, this solution will not work. The reason being, you cannot pull 100 gigs of data in a 10 GB RAM. So it means that this solution can work only if the files can fit in memory. So let's say this solution can be optimized only if my table size is small. And start realizing now that you have your table and you keep running analyze command there, because somehow this database says that if I have some stats around how big my table is, I can use different join optimization, and this is one of the optimizations out there. Just keep in mind, folks, all the folks who have some understanding around map reduce part, this is how you do joins even in your Spark when we say There's a possibility, I'm saying. I'm not saying this is how exactly it's done. There's a possibility that you can optimize by doing a join on the map side itself. Let's go for the other one. The other one is like you are doing line by line. What I do is I don't want to pull any data from any of the files. What I can do is I can just read one line from one file. Then I can start reading rest of the lines from the other file one by one. And whenever there is a match, I display it. Here, what is the beauty of it? Doesn't matter what is the size of my file. It's a 100 gig file, it's a 500 gig file. This solution will always work. The reason being very simple, that I am reading only one line at a time from both the files. So my memory footprint is minimum. Let's say the first line in the first file was 1 kilobyte, second line in second file was 1 kilobyte. I am just having a memory footprint of 2 kilobytes in my RAM. So this solution is foolproof. It will always work. The only challenge will be it will be super slow. So I write join whatever join table one comma table two, where table one dot country is equal to table two dot country, and that's how you're able to join the join, right? But this join will be super slow. It will never fail, but it will be super slow. So first case, it will be super fast, but it can fail if your table size is more than your RAM size. Second case, it will never fail because the memory footprint is too low. But end of the day, what can happen is the process will be super slow. The third one, which is the optimal version. I am aware that my country, comma, capital is a very small file. I will cache it in my RAM. Just keep in mind, folks, when I say cache it, it means that I will use a data structure. Just keep in mind all the data structures that you're aware of: list, array, dictionary, or hash map in Java, or set in Java, or array list in Java. They all have only the RAM footprint. And whatever is in RAM, you can access it at a lightning speed, because the IO of a RAM is 1000x, or maybe more than that of a hard disk. And that's why the word cached is used there. So cache has two notations, right? First is from the cache you can do any kind of lookup, read, write at a very fast pace. Secondly, caches generally are ephemeral in nature. It means that cache, just by the definition of cache can be invalidated, cache can be removed. That's the reason all your data structure, when we use, is like a cache, because you have a very fast pace of working with it, and at the same time it's ephemeral. If your computer goes down or if it's deleted, the cache will be gone, but your actual data will not be. So here in this case, what we are doing is the country capital, we are caching it, or let's say saving it in a hash map or a dictionary in Python. But the user country, we are reading line by line from the file, doing a lookup and sending back the response. So that's how you have the three different options to do a join. Just keep in mind, this is exactly what your database or the Spark SQL parser does, or a Hive SQL parser does. It looks at the SQL, looks at some information, meta information about the data, and then tries to figure out how should I do the join. Something again I want to emphasize on that. Do not assume that your database is doing something magically. Some people have written code to it, even to do, like, translate each and every operator to the file system operations. Example, when you say a group by pretty much means that, hey, it gets translated into a code, and the code knows that how to read the file, and for a common key, get all the values together. Somebody has written the code for it. Maybe you haven't written, but I'm saying whosoever has created a database, they have written the code for it. So that's how all your joint operations are done. That's how all your group by operations are done. That's how all your filter operations are done. None of the databases understand SQL. SQL is passed into what's known as the logical plan and physical plan. So with this, I'll take a pause, and in the next session, we will go for a code deep dive into this aspect. Thanks a lot, and see you in the next session.